Autodesk 2013 and compare it to, Autodesk products, think of Release 2009, Release 2010, Civil 3D, and Revit. There is a very, very significant increase in the technology between those product versions, and we just want to convey that message and get people to understand that it's not a single piece of software that does pretty much the same thing as it did 3 or 4 years ago. It is now a suite of software that affects our process and allows us to design, construct, and operate and maintain buildings and infrastructure in a whole new way and in a much more efficient way. The three kind of key things that we're zoning in on when we talk about Autodesk's 2013 suite of products are, number one, that they are very well integrated, right out of the box, and we'll talk a little bit about that as Reem goes into our presentation. The interoperability between these applications, and again, it's a whole suite of applications that range from Civil 3D to some of the analysis packages to things like Navisworks to allow us to do utility conflict detection, to cloud-based technologies that allow us to use this information wherever and whenever we need it, using almost any device that we need. So integration, interoperability, and then collaboration using things like cloud technology are starting to really redefine how we go about the project delivery process, how we go about designing, constructing, and operating and maintaining the built world. So with that, I'm going to jump right in. I'm going to introduce Reem Asaf. Reem is a resident civil engineer here at Microdisc. She's a solution specialist, and she spends the vast majority of her time working with Civil 3D and the infrastructure design suite of products. So with that, Reem, I'll turn it over to you.
Thank you, Mike. As Mike said, my name is Reem Asaf, and I am a solution specialist here in the Civil Survey specialty. And today I'll be talking to you about Civil 3D. So the 2013 release of Civil 3D focuses on a number of key areas that will enable you to get more from your designs. Today, specifically, we'll be covering the ability to model pressure pipe networks, the exciting addition of railway design tools to the transportation functionality, and as well as we'll be discussing interoperability with Infrastructure Modeler and cloud storage and access advancements. So many types of civil infrastructure projects require pressure networks for both water and sanitary sewer design. In the past, designers who wanted to use model-based design for pressure networks were lacking the pressure network tools, which prevented them from taking full advantage of the BIM process. Civil 3D 2013 introduces pressure networks, including a large, out-of-the-box catalog of pipes, valves, and fittings in a variety of materials and sizes. These intelligent 3D objects help enable you to create and document detailed pressure network models. The new pressure network tools help streamline the design process. You can create your pressure network in either plan or profile view and take advantage of content-driven layout tools that understand how a pressure network should fit together. You can then use built-in design checks to help you meet manufacturer and local standards for deflection, diameter, connectivity, and radius of curvature. This kind of smart design of pressure networks in Civil 3D 2013 means that you spend less time on mundane tasks and spend more time checking the design against your objectives and a water system or force main that better meets the needs of the client. Moving on to transportation, in previous releases there was no explicit tools for the railway designer. While all civil engineers could benefit from the power of Civil 3D objects like surfaces and corridor models, the geometric design requirements of a railway alignment couldn't be defined. So in this release, we have a new alignment type that includes special features for rail, like chord-based alignment design and labeling features. This alignment also helps provide necessary information for modeling CANT, so now railway designers can also be included in the BIM process. Civil 3D 2013 includes a customizable rail subassembly and also includes new tools within the subassembly composer to help you create your own custom subassembly, which is a more accurate model to fit your unique project requirements. Also new to the 2013 release, we now have direct interoperability with Infrastructure Modeler, which means with one click, we can export utilities and railway designs from Civil 3D into the Infrastructure Modeler for additional visual tools and animations. Likewise, we can also bring information back over after we've conducted an alternatives analysis of separate proposal to do our design and analysis in Civil 3D. "2013 is the year of the cloud, as Infrastructure Design Suite users have free cloud access and storage using Autodesk 360, which makes it easier to share, store, simulate, visualize, and collaborate your design files. This, in addition to the free mobile app, AutoCAD WS, makes it possible for anyone, anywhere, to download files on their iPad, iPhone, or a mobile device, leveraging cloud computing to extend AutoCAD products beyond the desktop and into the field." So with all that said, let's actually hop into Civil 3D and actually see how all these new features work. So here we have an existing site, and let's use our pressure network tools to lay out a new pressure system. Using the layout tools, we have our own parts list that includes a large out-of-the-box features of valves and settings, like I previously said. And now using these layout tools, we can actually specify cover, pipe sizing, fitting features, angles and sizing, as well as valve sizing before we lay out our pipe network. Once we're ready, we can just go ahead and draw it in using the intelligent features of the Civil 3D surface model. Now, as we're drawing it, you'll notice that you see a compass view, which displays all the different available bends, and that will place the correct fitting depending on what bend you choose in order to maximize that intelligent design that you want to lay out. So we can continue laying out our pipe network, and once we're finished and happy with the way it looks, we can even add in, say, a valve to the end of it, and it will naturally connect up with our pipe invert. Now, if we take a look at this in the object viewer, we can actually see that this is a 3D intelligent model. It's not just a fake 2D piece unit. So this can be brought into Navisworks for clash detection, as well as taken into the 3D realm to just view an intelligent network instead of just a bunch of lines. Now, we have those labeling capabilities that we're familiar with Civil 3D, so we can pull them out. They're dynamic. They stay along with it. We can also create a dynamic alignment that follows along with our pressure pipe network and any changes that we might add to it. Likewise here, let's create a profile view and take a look at our pressure pipe network compared to our existing ground. And as you see, as we add in our pressure network, it automatically incorporates all the pieces of our network to our profile view and any additional ones that we add on later on. So here we have an automatically laid out profile grid featuring our pipes, our elbows, our valves, and our existing grounds. Now, just like with our plan view, we can also grab our pipes and label them automatically in order to view our Civil 3D dynamic labels. And once again, in case we have labels that sit on top of each other, we can easily pull them out and move them around for ease in viewing that profile view. So we're happy with our plan, we're happy with our profile. Let's go in there and actually conduct some analysis. First thing, we can do a design check. And when we run this, we can actually specify what kind of parameters we wanted to check: deflection, diameter, open pipe sizing. And here we see that we actually have a violation, that there's an open connection. So to fix this, I'll go ahead and add a valve to the end of my pipe system and rerun my design check. And once I do that, my violation is gone and it automatically updates. Likewise, I can conduct a similar analysis with a depth check to make sure that my design fits in with my minimum and maximum cover requirements. So I just specify the run of pipe that I'd like it to analyze. And in this case, I'm just going to choose a minimum depth of 3 feet. So my command line is telling me I have 2 warnings. And if I hover over either one of my violation symbols, I can tell what my current cover is and think about the ways that I want to solve this issue. Likewise, here my pipe is actually above my surface, which is a little bit of an issue. So taking a look at my profile view, I have various profile view profile layout tools to help me adjust my pipe layout. So if I open up that specific contextual ribbon, you'll see that I can curve my pipe, I can follow the surface, I can break it, or I can delete it, depending on what I need to do in order to meet my standard. Here I'll put in a sag curve. And I entered in a 2,500-foot radius, but I didn't like it, so I can actually grip edit that to fit the feature that I want. Naturally, I can rerun my design, my depth check once more to clear out the symbol. Now let's change gears a little bit and talk about railway tools. So right now we have an existing railway alignment and then a new addition to it. And we can actually adjust alignment feature settings for cant options as well as measure railway curves along chords to get the chord-based alignment labeling that we want to see. I can go into my alignment properties and then change the type of alignment it is to a railway in order to enact these feature settings. Furthermore, I want to put in some design criteria, and Civil 3D actually has an out-of-the-box design criteria file available for us to use. So once I apply my 60 mph limit, I can go over to my design and see that I actually have some violations regarding my radii and length of tangency. Now, I have 2 ways of kind of solving this. I can go into this geometry editor and edit my radius, sizing, and lengths. But personally, I know that I actually have some constraints here where I can't toy with the geometry too much. So as an engineer, I've decided to make the executive decision to change my design speed along this curve to 30 mph. So I can easily select a new station for this new design change and just tell it that I actually want it to run around 30 mph right along that curve. Now, it's worth noting that while Civil 3D includes rail design standards for rail, it can be customized for any sort of specific object. The whole purpose of these design criteria is to avoid manually checking each element against the standard using the traditional methods of lookup tables and manual calculations. Using this method will actually save you time and allows you to take advantage of design criteria. So you can spend that time adjusting your design instead of looking up each element table by table. So now that I've cleared out my violations, let's talk a little bit about building my rail corridor. So here we have our rail subassembly piece. This is the out-of-the-box piece. Once again, we can go into Subassembly Composer and customize this as we want. And now you're seeing our newly streamlined corridor creation. So no more step process. It's just a one-step process to build our corridor and target our surface. And if we go over and take a look using our zoom tool, we find our finished corridor. Now, this corridor looks good so far, but I actually want to take advantage of some of my cant analysis features with my alignment and adjust my corridor accordingly. So I'll go ahead and go into calculate my cant. I have a few different options for how I want the pivot to work, and also another customizable design criteria file where I can specify my cant design standards. I want to also automatically resolve the overlap on this, so I don't have to deal with figuring out my transition ins and outs and associated grades. Once I produce this chart, I survey it, I like everything about it, and I can actually visually take a look at this as well by going into my section editor in my corridor tools. Now what the section editor does is it very nicely lays out my plan view, my profile view, and my section views of the corridor and the corresponding place in each with an orange line. This is really nice because I'm able to actually interactively take a look at each one of the pieces and adjust them as needed. So now I'm snapping to a station right along the middle of that curve. I can see how my cant's been affected, how that tilt is occurring based on my cant analysis. And let's take a look at another little section over here. And I like this section view. It looks good to me. This is a good adjustment for that curve. So once I'm happy with this, I can actually close it out and go back to my plan view only. Now, if we want to take it a step further, we can even create a cant view, which allows us to take a look at the transitions in and out in a graphical nature. Finally, let's use this interactive drive feature to review our railway alignment. We can choose to drive over any feature line along our corridor, and what you're actually seeing here is a composite surface using new 2013 features on using existing ground and the corridor surface as a height boundary. This allows for the ultimate integration of your existing and your proposed surfaces. Now, we also have this 3D wireframe option where we see different line weights for the feature lines associated with our corridor. We have the option to switch our design speed in case we want to test out a different speed for this railway alignment. Maybe this is going to be an Acela train, so we want it to go 90 miles per hour. And we can also hop to another station and see how does this ride along my curve specifically. Now also remember, using that direct interoperability with Infrastructure Modeler, I can then export this out to IM and add some animations, add sunlight shading analysis, and really create a nice visual object for shareholders and community members to review. Okay. Now with that, to recap, we've gone over a number of new features in Civil 3D 2013 today, namely the addition of pressure pipe modeling and analysis, railway and cant design toolset, the streamlined interoperability with Infrastructure Modeler, and the cloud access, storage, and collaboration. With that, thanks for tuning in, and I'll turn it back over to you, Mike.
Reem, thanks so much. It was a great presentation, and certainly looks like there's been some significant improvements in Civil 3D 2013. So what you saw Reem just show there was, just really significant improvements in, the design process within Civil 3D. And as I mentioned earlier, when we talk about integration, the interoperability and the collaboration, I do want to talk a little bit about the Infrastructure Design Suite, and there's 3 different versions of it. It's the Design Suite Standard, Infrastructure Design Suite Premium, and Infrastructure Design Suite Ultimate. And it's a suite of products that all work together. One of the things that Reem had mentioned there at the end was cloud. And imagine with all of that design information that we can create within Civil 3D, being able to push that information up to the cloud and access that information anywhere, anytime, using devices like an iPad, where we can go through and we can look at a lot of that different information using AutoCAD WS or Autodesk's Design Review. And if we move on one more slide, a few logistics. So Reem gave you a high-level overview of what's new in Civil 3D 2013 and what we saw as some of the more compelling features. If you'd like a more in-depth look at Civil 3D, we will be holding full webcasts in May, and you can figure out the schedule and identify when you can attend by looking at microdesk.com at the URL that you see there. If you're interested in more immediate information on Civil 3D 2013 or the Infrastructure Design Suite, please reach out to us. You can reach us at the phone number and/or the email address that you see on the bottom of your screen there. So again, when we think of the complete suite from Autodesk in 2013, think about that integration, the way that we can, the interoperability that we have between their applications, whether it's Civil 3D and Infrastructure Modeler or Civil 3D and AutoCAD WS, and definitely think about the cloud. For Design Suite users, if you're using Design Suite Premium or Ultimate, Autodesk has significantly increased the amount of storage space that you have in the cloud, as well as the computational power. So the number of computing units that you get when you purchase one of the design suites is significantly more than you have with Civil 3D alone. And with that, I want to thank everybody again for attending. Thanks for spending some time with us this afternoon. I hope that everyone found Civil 3D 2013 as compelling as we did. Any feedback you might have, we are definitely open to. We love receiving feedback, and I hope everybody has a great afternoon. Bye-bye.